Hey there guys, and welcome back. So we are back to this mess. There are a number of things. One of those things over the past week while I was on my break, I did spend a little bit of time thinking about this, and let's go ahead and talk about it. So again, the way I have this set up, the bottom half is going to be the half that is going to have to move because we have the screw in the top half. That's not 100% true. We could change the way it works, but I think that's the way it's going to work at this point. We could, again, redesign this to work differently, but not really in the cards at this point as far as I can tell. So, for example, this screw part, I was considering moving down to the bottom and having this stationary, and the screw part or the handle could move the bottom part, or the handle could be attached to the frame and move the top part and the bottom part at the same time. Those were all ideas I had going into, that I considered while I was on break. Just one of those things. I was trying not to work too much on stream stuff while I was on break, but I really needed to, because this project needs to get done. I really needed to at least have an idea of what I was doing coming into this, because obviously I did not think very far ahead to begin with. So those were other options. Those were alternatives. But that is not where we're at. What I have decided is, in order to get this into height, to adjust this in height, aside from the fine adjustments with the screw, I believe what I will be doing is attaching it to the back. So I will go ahead and put little thumb knobs and T-nuts connecting it to the back of the extrusions, and that's how we'll lock it into place. And then again, the handle will come out here and allow us to go up and down like this. The fine adjustment with the screw, that one is going to basically, if I'm thinking about this correctly, I'll put a hole in the extrusion up here and then collar it off. That way the screw actually moves us up and down, and otherwise we can take the collar off on the top part, and that will allow this to slide up and down all by itself. So that is how we're going to distinguish between the two modes. Either we adjust the collar and set it into place and then screw down the collar to adjust this up and down, or we attach it on the back. We lock it down on the back, take the collar off, lock it down on the back wherever we want it, and that's just where it's at. I think that's where I'm at this point. Again, there were other ways that were maybe a bit better to design this, but rather than scrapping the design and starting all over, I decided to see how this one works out. One of those things. It's at the very least an experiment to see how well it works, and we can always create another one if we need to. One of those things, this overall size is a size that I want. So even if I scrap all the plastic parts, I still have all the metal parts available and usable. So it's not that big of a deal if this doesn't work out. Just wasted some plastic, and one of those things. 3D printing, do a lot of 3D printing. We're going to waste some plastic. So I'm not too sad about all that. So. I guess we will start out on the back part then, just to get that into place. I'm not going to model up the lead screw, at least not right now. Maybe I'll come back and model it up later, but it seems highly unnecessary because with the exception of putting a hole in both of these guys. So again, these guys should be identical. I'll put a hole in both, and the bottom end can retain the lead screw if we need it, and the top part will obviously go straight through, allow it to pass straight through and up through the extrusion. So I might model that in, but otherwise modeling in the lead screw at this point is a bit unnecessary. So I was right clicking this and accidentally got the drag feature, the gestures feature, because I want to do find in browser just to get us all the way down here. So this is carriage body, and this is top carriage. And again, the idea here is, do I need to thicken this up? Let's take a look at the right hand side. Right. And here's my extrusion. So we do have a bit of meat between these, and I can actually, rather than just looking, we can actually measure that. So that would be a 7mm chunk of plastic right there, which actually sounds plenty fine to me. So I am content with that. The only question is when we do the handle, whether or not I need more room for the handle. I guess that's something we'll find out. I'll go ahead and just bring these tabs straight out and then attach them to the extrusion. Or at least, well, really they're just going to be wings. And then the T-nut, I can put a regular T-nut through and it'll bolt. Although it's one of these deals where in this kind of situation, it'd be better to have a hex head bolt. And unfortunately, all my metric bolts are either socket or... Actually, do I even have any? No, they're all caps and thumbs, except for the 2.5s, which are pans. So I don't have any hex heads. Or not 2.5s, my M2s. My M2s are pans. I have those as pans. But point being, I do not have any hex heads. Is what it comes down to, unfortunately. At work, I have 1/4 inch, and I do not have 1/4 inch T-nuts though. 1/4 inch is about 6mm, and 6mm would fit into this extrusion. So that was almost a possibility there. Unfortunately, it sounds to me like it won't work. 2mm. I just want to double check that, didn't I? Okay, 1/4 inch is 6.35mm. I knew it was close to 6, but 6.35mm actually may not fit into the extrusion to begin with. So that was a little bit of a, what do you call it? A wild goose chase. Wild juice chase. Yeah, nice. Wild goose chase. There we go. Alright, so I do not have a back of just yet, so we'll go ahead and make that. Back of top carriage. Do I have all this stuff labeled? It looks like I did. Very good. Excellent. Good job, me. Where's the group 1? I don't particularly care. That's not labeled. And let's hop in here. Where's my sketch at? This is extrusion positioning layout. Position locking, let's call it. Locking layout. Cool. So we can grab this, and I'm going to go ahead and honor these holes. Actually, I don't need to honor them because the point being is that we only need to get, we're actually going forward. So that actually does not matter. So I'm going to grab the outside of the extrusion here, and yeah, I think I will just mirror this across to make my life simpler. So we need that, we need the center. Where's my center? There's the center of the extrusion, and that should be everything we need. So project. Let me go ahead and turn the frame off because I'm having some difficulty seeing this. Turn the bodies off. Lower carriage, handle. We actually haven't done anything with the handle. Rails, come back please, don't do that. And frame. Alright, cool. So, that is funny. I thought I grabbed the outside is what I was trying to grab, and it looks like I actually grabbed the face. There we go. Alright, construction lines. This one is my center, so we need to grab center of that. And I will make these M6s, I think. M6s do not slide out of, the M6 nuts do not slide out of the extrusion. So once these are in there, they're in there forever. Which I don't anticipate being an issue, but could possibly be an issue, admittedly. Alright, and this is basically my wing. We only really need two, because we're going forward and we're not actually going back, we can just line this up on the side here and extrude forward. So that is what I'm going to go ahead and do. And hopefully this lines up correctly. It looks like it does. I probably shouldn't have done this. I probably shouldn't have midpointed this. I probably should have put linear. But that is where we're at right now. Toss that on there. So that's the outside. So this wing is going to just hang out all the way on the outside. We could consider doing something funny like hugging the extrusion. I just don't see any benefits in that, so that is why we're not. This is going to be a 6mm. 6mm? Oh, huh. No. That's diameter. 6. Okay, evidently my fingers just suck. Right. That's funny. Alright, obviously 6 is right above 3 on the keypad, and obviously I just missed, obviously, multiple times. So, very simply, we are just going to extrude this out to the extrusion. Easy peasy. Turn the body on. Where's my body at? There we go. Minimize some stuff. Hit the join button. And mirror that across. Create mirror. Feature. This should still be on the mid plane unless something went horribly wrong. We'll do a quick spot check. So we'll grab this, which is the outside of the extrusion, and that, and 1.5 millimeters. Okay, it's 1.5 millimeters between it. Okay, that is acceptable. Wait, unless it's one. No, that's definitely. Here's my front view. Yeah, they're definitely in line. So yeah, that is 1.5 millimeters just between the faces horizontally, as opposed to along the x-axis. Q. That is fine by me. Now the next question, and this is something that I was also considering, this bottom carriage. So let's turn the bottom carriage on and hop back up the carriage body so we can see everything solid. Obviously, that is the only thing holding that, or that is going to be holding that, I should say, to the upper carriage is the handle. So we would lock the handle in place, and that would be the only thing holding it together. That may not be a good idea. We may want to put wings on this as well. But I am going to go ahead and leave that alone for the moment. And if we need to go ahead and do that later on, we will. But that is definitely a consideration, is adding a second set of thumb screws here to screw it in, to lock it in place. We could also, actually, yeah, so the place where that would be most important, which is what I kind of stopped myself on because I wasn't sure how necessary it is to say it, but on the fine adjust. When we're doing the fine adjust, the point of that is getting to a specific height, and therefore that makes a lot more sense to have the extra wing nuts there holding this together. However, I guess the other option would be to have some kind of clip or something. So add maybe another feature on the back here to clip this up onto that. Clip and or fasten it up onto it. That would be the other thing. So for example, we could have a, let's see, really quick, just sanity check. Yeah, okay, both of these want to be printed standing up right now. So exactly like this, looking down on the print bed, this is how they're printing. If the print bed is right here, this is how they're printing. So for that reason, we could add, for example, a little shelf out the back, and that would still print all right. Obviously, this guy, we'd have to have a overhang to, a loft, what am I looking for? A draft. We'd have to draft this up so that we don't have to worry about the overhang. But we could then put, like, for example, captured nuts in the top one and bolts in the bottom one, or vice versa. It might make more sense to do vice versa. And then actually bolt these two pieces together when we're not using the handle. Again, that's a design consideration that maybe we add in the future. Now, on to the handle, which is the next important part. So, do we have a left side of top carriage? We have a right side of top carriage. I will take it. Either side works. I am not... I was going to say I'm not prejudiced, but I'm slightly prejudiced left to right, but that is beyond the scope of this topic right now. Turn my bodies off. Turn these off. Actually, I take that back. You guys can go back on and you can go back on. I will just turn that off. Makes more sense. There we go. So yeah, we lost a little bit of space here to put the handle mechanism, but one of those things, as I always say, I will cry about that later. And I will, this is the way I was thinking of doing this handle mechanism, for the record, is line this up. So we're going to have two 8mm rods here that the handle rests on, is my idea. I'm using 8mm rods just because it's a handle. If it was something that I wasn't going to be pressing on so hard, I would make it out of plastic, but the handle itself is already going to be plastic, I think, unless we need to change it over to metal anyway. So I wanted at least part of it to be metal so it's less likely to break, especially because this part right here will be attached to the main body, and therefore there's a potential that if a part of the main body breaks, that's a lot more printing than if this was a separate part, if it was a separate metal rod. So that's the idea. So we'll have let's go ahead and look at this, two rods that the handle attaches to, and then how do I call this? A lever action, I guess I'll call it, here. So the handle goes this way, and then this attaches to a part of the handle. When the handle goes down, that pushes on this lever arm, forcing this down. This obviously cannot swing backwards, which is what it wants to do, and we'll slide down the rods instead, and that is one of the reasons why we have bearings on the inside, to relieve some of that stress. So that is the plan. Meanwhile, obviously the the 8mm rod sticking out the edge here needs support on the other side, so we will have to build something around here for the 8mm rod to be supported on the outside too, because the 8mm rod cannot run straight through, because obviously we have this screw going all the way through. We have this screw coming through. Actually, it looks like I did not put the screw hole in the bottom one, so let me go ahead and amend that really quick. Let us back up here. Let's see. Yeah, I can do it here. That's fine. Actually, I take it back. Let's come all the way back. Yellow is the lower carriage. Yeah, yellow is the lower carriage. So let us go ahead and track down the screw. Is that back carriage design? Let me turn the top carriage off. Yeah, okay, there's the screw right there. And distance all, flipperoonie, and there we go. So that will allow the screw to pass through the bottom carriage safely. But anyway, because we have these rods and the screw in the way, we can't actually run the 8mm rods straight across for the, which was the point, for the handle, to support the handle. And therefore it needs support on the outside. QED, to be fancy with the language. Quod erat demonstratum. I think that's right. Quod erat demonstratum. Alright, so there's our 8mm rods. They need to be held in place on each end, so we'll go ahead and give them a 4mm buffer. Collar in the plastic. We'll get some coffee. The handle is going to come off of here. The handle we can go ahead and make 4mm as well around the shaft. So I'll go ahead and use this as part of that. And here is those lever arms that I was talking about. So we have one going up this way. The angle right now is not exact. I was trying to get tangent, but that obviously did not happen. Tangent, there we go. And right angle up here for the sake of it. There we go. Alright, so that's right angles, so these should be the same distance here. So for example, this should be 8 plus 4 is 12. This should be 12 right here. That is 21 right here. So, this also needs to be a right angle. There we go. Now it's 12. 16. 4 and 4 and 8. There we go. I can math. This is a radius. This isn't a diameter. We can do the maths. So that is a 12mm piece of plastic at this point, which is a lot of plastic. So recall when I was talking about maybe changing part of the handle to metal if we needed to, if it started snapping. That was not my ReZero impression. That was just me humming to myself. Yeah, that may actually be the best idea. Let's see. That does complicate the design a little bit, because we will need to tap into this using that. So to hold it in place. Although, to be fair, if we're doing that, that does give us the benefit of being able to adjust how this goes. So, for example, if this, let's pretend. So I'm gonna actually change these over really quick to be the rod, which means that we'll take this off of here and tangent this like that, and click that, and take that off of here. Try not to double click, tangent, and quinky dink. There we go. So now we have an 8mm rod. Told you. So here is, in theory, our 8mm rod. We're going to have the other rod. I actually do not want it quinky dinked with that other line, so we will fix that problem. And we'll have to manually do stuff because Fusion never understands what I'm trying to do. There is tangents, and there is right angles right there. So if these are both 8mm rods right here, obviously, well, not obviously, but give me half a second to toss the center line in here, and I will center this on, or I will put the center line of this rather on that line. I will not center it on that line, I will put the center point of that on this line. Okay, so this, technically speaking, can go anywhere like this. It can't really go here because that overlaps what we're doing right here, so it can't really do that. But we have some room for adjustment, and by using two rods and pinning it in place at various places, I can figure out what really works best to some extent. I say to some extent because obviously we can't, you see how the length of this rod is changing as I do this? We don't really have that flexibility in real life. In real life, we do have the ability, and this one is not changing, so this one doesn't. The top one doesn't matter. It's only the bottom one that's going to change. However, we can start out with a long rod, okay? And let's say I want this to start out. Yeah, and Fusion is doing silly things. Doing silly Fusion things is what I meant to say. So let's drag you back down. So what I was going to say is we could start out with something like this, where we're just barely scraping by right here, okay? And we could start out with this attachment and this length on the handle, and then as we decide that this doesn't really work terribly well, we can go ahead and shorten this arm up, and as we shorten this arm up, obviously this angle that the top one is off will just compensate for the fact that we're getting shorter. So that does give us some flexibility. Now, I believe the length of this rod does dictate our stroke. So we could also determine an optimal stroke, or maybe not an optimal stroke, but a target stroke for what this arm should be. So for example, I could sit here and go, this arm, our target is going to be 3 inches, 3-inch stroke. I don't think this actually works right here because I think this, the distance from here to this edge matters, I believe. But I could be wrong because honestly, it's one of those things, I normally just make stuff, I don't do math. So that's where we're at. Meanwhile, this one, again, can be literally anything, whatever looks good to us. So we can make this 6 inches, let's say. That is 6 millimeters. Control Y. 6 inches, and we could just call it that. Now, if I look at this in reference to the frame, let's say, you know, it actually does not stick up above the frame, which is nice. So maybe that's where we want to start out with. The only other question is, well, all right, I take that back. We actually don't have to dedicate this one necessarily to 3 inches right now, because it's going to work one way or another in the model. So when I actually print everything out, because this is just a rod, I can cut this rod extra long and start testing from there. So that is the deal there. The only thing left to say is I kind of would prefer it not stick out too far from the front of the frame, which is a combination of two things, right? It's a combination of what angle we can get on it. So if I drag this back a little bit, you know, let's say, actually, rather than drag back, let's say this tangent is our minimum, which may or may not be true. We actually, so I've been saying that, but, the fact of the matter is that we're not really going to collide with anything. Oh no, that's right, because we need to attach this rod to the other rod, so we're going to have a 4mm buffer in theory down here, which we may, well, this rod's going to be outside of it, right? It's not clear at this point. It's not clear. So I will just do that, okay? And that is where we're at, honestly, because if I change this, let's say 5, as you can see, that broke. That most definitely broke. 5 inches, and now we're out the backside. So let me delete this. Deleted. If I drag this up, as you can see, that does get us more of a vertical angle, so that does have a benefit, but the change is very, very low. It's obviously a little parabolic, or I guess exponential, something along those lines. It is not linear, because as we get here, as you can see, the changes here to there is much more subtle as we go through the range. So one of those things, it's a consideration at any rate. I think I might call it 4 inches to start out with. And this guy at this point is still below the top of the frame, so I believe that is acceptable to me. So that is, let's come back over here. That is the handle design. And now we need to go ahead and hop actually back over to the top and lower carriage and actually get this side attachment out of here. And let's see, I think I'll put it at 4mm and go from there. So 4mm for this collar on this side. Anything else I need? I don't think there's anything else I need right now, so I'm going to do that. We are going to, well, I'll go to lower handle and do the same thing again. And I will go ahead and use the other one as, not all to object, the other one as a reference, so that I only have to update one. Let me come back up to here so that I can rename these. And that guy right there is rename. That is the screw hole. Pass through. Is that too many S's? No. Hole. And then we got rename. Upper handle collar. Lower handle collar. Alright, cool. Keeping organized. Doing the right thing. Being heroes. Alright, now. I will go ahead and come down here and put the rods in, I think that's what I'm going to do. Let's see. So the option is, do we do one object for all the rods? one component for all the rods, or do we do each rod as its own component? I think we gotta do one rod or a component for each rod for the sake of assemblies. I think that's how I'm gonna have to do it. So new component, or actually, you know what? I will just extrude a new component. Save myself the clicking. And this guy, so if we map this out, each rod is 8 millimeters in diameter. So we gotta get out of this one, plus 8 millimeters, which is the rod diameter, plus the holder for the rod. So the rod, now that this isn't plastic, now that these rods are not plastic, they're going to have a plastic sleeve that attaches them to this rod, which is probably going to add another 8 millimeters, 4 millimeters on each side, which is a lot. So we're up to 16 plus 4 is 20, and then we need 4 millimeters at least on the other side to hold the other side. Yeah, this is getting a little sketchy at this point. So we're up to 24 millimeters. Okay, all right. Good news is that we still have space. I was actually concerned that 24 millimeters was going to run into this extrusion, but it doesn't. But the lower one, the lower rod, is going to be sitting next to the other rod, but we can subtract off hopefully we can subtract off the 4 millimeters. We'll see how it looks. So we got to go another 8, so that's 32. That is right there. Actually, that is not right there. That is literally through. So now that I've changed this to 8 millimeter rods, we have an issue now. This does throw in. So when this was plastic, I figured plastic would not be as big of an issue. Okay. I got it. I think I got it. Yeah. Okay, we should be good. So I am going to generically go. I'm not going to do this actually. No, I take it back. I'm not going to do this. I'm going to design the holders first. That's how we're going to do this. Yeah, I think we should be good. I think we should be good. So we are going to new component. Yes. No. I will go ahead and extrude this out from here, from object, and we will go 8 millimeters. I think I'm going to go 8 millimeters to start out with. That's 85. 8 millimeters. I think this works. Let's go. 8, and 8 is 16. Do I want to go 16 right now? We don't necessarily need to go 16 right now. So the idea is I was going to have the rod come all the way down to this rod and bump into it. That was my idea, but we technically don't need to do that. We could actually put the rod up here above all this, and therefore we could loft this out if necessary to hit that other rod, to hit the place where it's held. So that is the concept I am working on right now, the premise I am working with. So question is, do I want to start at 8 or do I want to go bigger? Because we do have space to go bigger, we just can't go too big. What's 16 look like? The 16 makes my life a little bit easier, is the point. So. do 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 do. Let's see. I don't think we need the 16, and the reason being, so now that this is metal, actually, my original plan was to pin the handle in place at the highest point into the plastic. Just pin the plastic straight through to the other one. That doesn't work as well. Huh, I've thrown a bit of a wrench into my own plans. Alright, well. Let us consider. I am going to go the 16 for right now, just because it does make my life easier. Although, actually, you know what? That doesn't. I just realized it doesn't necessarily thwart my plans, because we can always pin through. We don't have to put the rod all the way down here, as previously stated. The rod can be up a bit higher, leaving us space to put a pin through the plastic. Okay, so there's that. Okay. Let me readjust the pop filter here. There we go. So, there is that. This is rename top handle attachment. Copy. Paste. I just fat fingered something. What does that actually say? Okay, it was just appeared. Cool. Alright. Let us see. So, we hop in here. What did you just do? Why? Why did you change your name back? Don't be silly. Alright. I need a tangent plane. I'd like the tangent plane to be quinkydink with this guy. What is the best way? I guess the best way actually is to do this. Toss that, right angle it. I'll make this a construction line. Toss that tangent. And I think this is the best way. Line at an angle. There we go. And I want that at 90. Yeah. Okay. That seems to be the most convenient way to do it, if I'm thinking correctly. Now, point being is that I want to project this out and get the center line here. Let's turn some bodies off. This is, I cannot rename this here. This is top handle perpendicular plane, mating plane. I guess that's what I'm going to call it. And our sketch here is the top handle rod attachment. And we will go ahead and get our center, throw in an 8mm right here, and for the time being, I will go ahead and do it this way. So, because I gave myself that space, for the time being, we will go ahead and just tangent like this. Again, in the future, it doesn't necessarily have to be right there if we need to change it. So, next thing I want to do is, let's see. what is the best way to go about this? I think the best way to go about this is to hop back in here and toss and do the same thing with the... Basically, I want to be able to loft this up to make it easier. So putting another tangent plane right here, again, quote-unquote tangent plane because we're using plane at angle instead, to loft it from is probably better. And plane at angle 90. Okay. So where did that go? Oh shoot me. Wrong place. Construct. Plane at angle. There we go. 90. Okay. And this is inside tangent of top handle rod. Okay, so I'm going to make a sketch here, call this bottom of loft, and that will be, actually, you know what, that will be, it's questionable. There's two different ways I can do this. I could loft from just this, okay? Or I could actually take the intersect of the body and loft from the intersect of the body. That is another option. That was not the body though. That was a face that I intersected. Let's try the body. Turn that off. And turn the body off. Yeah, okay, there's the body. So, actually, no, okay, that is. It looked a little short. It is not. So. That is one option, to loft from this. The other option, like I said, is to not do that and just project off this. And actually not that, just this circle. And go from there. So, this is going to be bottom of rod mating loft, okay? And basically, I want to leave space again to go through the plastic with, say, well, we'll say a 3mm. Well, what am I using in this design? I think these are 3mm right here. I know I use 6mm in the back. Yeah, these are 3mm. So let's pin it with the plan on pinning it with a 3mm and M3. So in that case, we need. I was gonna say we need at least 3 plus a wall, but we don't really need the wall. We do need 5.5 because we need the head not to run into run into the collar here. So in that case we need 5.5 for the head plus a little bit of buffer room, so we'll call it 6. So I will go ahead and loft this up 6 plus, let's say 4mm, no, maybe 6mm to hold it to support the end of the rod. So that's 12. That's 12. Yeah, that's 12. Okay, so we will offset by 12. And this will be the top of the loft. Top of handle mating loft. And toss our sketch in here. Top of rod mating loft. I called it rod in one place and handle in the other. There we go. And now we can go ahead and project this guy out. Again, because loft doesn't really like multiple profiles in a single loft, we won't project the other one out. We will just extrude the other one from the original. So that is, wait a second, we went the wrong way. This should be -12. There we go. Much better. So now we can go ahead and loft. And this isn't even so much a loft at this point. I'm using loft just because if we decide to change this in the future, we can. But, so you can see how that looks right now. You can imagine if we went ahead and used the square instead, this would be a lot more interesting shape, which I'm kind of partial to. But the next thing to note is this arm right here is actually not going to be accurate. As you can see, it overlaps our collar right here. The only way that ends up not being accurate is if the rod is far enough out to not interfere. So, oh, actually, here's the other thing. This bottom circle actually, yeah. This bottom circle. Let's see. Okay, this is what we can do. I'm gonna join this really quick. And let me just make sure that I didn't screw anything up without thinking. Okay, no, it is. Oh, there we go. That I did screw that one up. Let's see. Yeah, so that would have been a reason to use the intersect. So let's hop back over here. And there's a couple things here. Actually, no, let me all the way back here. Let's change this to 12. All right, so there's that. And now we got to come back in here and delete this and intersect this body. And I will toss that. Is it just that one, or do I have two? It looks like it's just that one, which is interesting. But let us attempt, see what happens with that. Yeah, okay, so this is what I was talking about. You see how we technically can overlap like this. Now that comes awfully close, but it's technically not a problem. So, we're going to be up. Let's see. I probably should use a third profile in the middle here for this edge, so it doesn't look so ugly. So let's go ahead and do that. So I'm going to come back to the middle part here, turn this on, and then toss this in like this. I think this should fix that problem. So if I come back in here, grab the middle one, grab that, and that, and that. Oh shoot, that's right. Control Z. That was not actually Control Z, that was just Escape. But I have to turn this off at this point, so it does not get confused. Let's see. Shoot, how am I gonna do this? Oh, I'll turn this one on. Yeah. Okay, so we can do that because we need to clear that. So, oh, that's not a complete. All right, Control Z, Control Z, Control Z, and you are not actually going to be tangent at this point because you need to not connect to that. You need to connect to that corner instead. I need to complete this box right here so that we do not run into the wall. There's that. There is that, and that does not need to be tangent. Alright, so there we go. Toss this guy in here. Toss that in the middle. Which profile is profile 2? Okay, yeah, so these need to be swapped. Okay, I guess I'm not swapping. Let me do this, do that, and that. Yeah, let's see. This is 3, so I want this one to be direction. And I guess that's the best I got at this point. So again, this comes awfully close to here. And when I extrude this out, let's come back in here, toss that in, and extrude that distance from object. And we said that that was going to be 6. So I guess that's the other direction. 6, cut. 6, cut. What just happened? There we go. So if we take a, let's see, a section analysis here, I will just grab that, and we will manually move our way back. Let's see, what looks like it's going to give me the most information. Anyway, the only place I was getting to here is, you see how close that gets to the edge here, unfortunately. That's the only problem we've got right now, which is that it does get a bit close to the edge, so we don't have as thick of a wall down bottom here. Whether or not that's really an issue, I guess I'll find out. And then obviously the only other issue would be the fact that this is so close to this wall. We can amend that though. We can come all the way back here and change this to 5 millimeters, and that will give us a millimeter spacing here. So that helps. Our other alternative here, which is valid, is I did this. I did the offset, the tangent over here, because I didn't want to run into the other rod, but we maybe can get around that anyway. The other rod may have enough space that I am overcompensating right now, so we could turn this back from tangent to being centered. Okay, so now it looks like this, and again, this can go back to being 4 at this point. So I guess I will go ahead and put this back to 4. I guess it's one of these things. I'm undoing this because I want to see how bad this works, and at this point we know that this is not as bad. We don't have as much of an issue over on this side with the wall thickness. So let's turn this off. That is a funny thing. Let me turn the top carriage off just to see if the other side also looks like that. It does. Let us look at that loft really quick, because it should be, I guess, change this to direction as well. Okay. Hit join. Yeah. You know what? I'm alright with that. It's one of those things. It's looks. It's looks. So, let us come down to, or not come down to, but create the bottom half now. Let's see. The rod for this part of the handle, I believe. Let's see. We can get pretty close is the point, because we're not going to go the full 12 actually on this one. This one has 12 because we want to put a hole right here in order to pin the handle in place when we don't want the handle moving. That's the point. So, for that reason, the rod I actually do not know how far the rod has to come out, in all seriousness. So this is, did I make this 12? Face, I did make this 12. So. We have an 8mm rod coming up here, which means that 4mm should be able to fit underneath here, in theory. So if we extrude this out from object here, offset by, let's say, 3mm, just to give ourselves a little bit of breathing room, and then we make it 12mm just like the other one. Okay. And then we go ahead and repeat the process, and that was the wrong kind of extrusion. That was supposed to extrude as a new object. So object, offset -3, and 12, and new component. New component, bottom handle attachment. Alright. And let us consider. Can I cheat? I don't think I can cheat. I was trying to think of how I could copy this down, but we don't really want to copy it straight down. It's not necessary because we don't. This is extra space. So I guess I'm just making a new one. So a little bit of extra work. So really quick, rename. This is the handle mating loft. This is the rod sleeve, upper rod sleeve, I guess that's what it is. Upper rod mating sleeve? I don't know, it's a name. All we gotta do is get close with our names. And the rest of these are good. Yes, the rest of these are good. With the exception of that guy. Whoops, get out of here. Rename. This guy is now the bottom handle attachment. Yeah. Bottom handle attachment. Alright, so going back to what we did before, we'll go ahead and toss these lines in here. That's already at a right angle, that's good. That is a right angle, that's good. Toss in tangents. Make them construction lines. Come back to the bottom handle. Create our planes at angles. And 90. Plane at angle. 90. Offset plane. And this one only needs to be -6. And we can go ahead and name those. So this was, let me just copy the names off of here. Wherever I was trying to click there. There's that. So we could do alrighty. And now we can go ahead and draw up what we need to draw up. I will, let's see, project out that guy. And then we can go ahead and toss our lines in here like we did before. We can toss our circles in here like we did before. Take our center lines like we did before. Do not right click gesture, rather. We centered this up last time. This is an 8mm and this is 4mm walls. There we go. And these are construction lines for now because we need the loft, unfortunately. I wish they didn't need to be construction lines, but we don't always get what we want. This is the bottom of it. So this is going to take the intersect of this body and Hit the sketch button, turn that off really quick, and make that construction. Turn that back on. So this is, grab this. Whoops, Control Z. Where am I on the browser? There we go. Copy, paste, bottom, copy, paste, bottom, or no, top, no. Ah! This should be top. Whoops. That one, bottom of top. There we go. All right, and now copy this and finish, and come to this plane. Whoops, not that plane. Yes. I want to make sure I didn't accidentally grab the wrong plane. Project that out and that out. Or not that out, actually. I take it back. Because, again, Lofty will not understand what I'm talking about. And now we can paste this in. Top of bottom. Okay. Hit the finish button. And Bob's your uncle, as they say. Bob was actually my grandfather, but that's a different point altogether. Loft, boink, boink, and boink, and join. And we did direction for the looks, and join. And extrude. Actually, I gotta turn that one back on to a solid line, and now I can extrude that one. And this can actually go distance all and flip Rooney because that's already at where we need it to be, unlike the other one. So, toss that off and give ourselves some names here. So, hop back up to handle so I can copy pasta. Rename. And that should not be upper, that should be top, because that's how we were naming it. Be consistent with our naming practices. Rename. Oh, we did not name that one. Top rod attachment. Sleeve. Rename. Wait, why is this pink and yellow? Oh, that's pink and yellow because I did all. Bad me. Delete that. There. Extrude. Distance to object. We can't use all. I lied. Cut our top into there. And then distance to object all. We can use all. Alright, I'm lying to you again. We can use all. We just have to make sure to deselect the objects to cut. Rename. Paste. Bottom. Okay. And somehow, I still have coffee left. Normally I'd be through my coffee by now. Obviously not drinking coffee for a while has reduced my need to drink coffee. And now, I just realized. Bollocks. Shoot me. It doesn't necessarily matter. We can do it this way. It's better if it's not done this way, but we can do it this way. So I've been talking about how this rod's going to go up. I'm not looking at the screen right now, so if I'm not gesturing in the correct place right now, I'm busy face palming. But the lower rod is supposed to go up past the upper rod and then be beside the upper rod when it attaches. That is not the ideal way to do it. Ideally, the bottom rod would be below the upper rod. That way the upper rod is pressing down directly into the bottom rod. Now, the pressures that we are working with here are not particularly high. So we can, as I've been saying, pin it across. However, I was also thinking I'd pin it when we were below. That was the other thing I was thinking. So the lower rod would go up, and again, if I'm not pointing in the correct place because I'm face palming, just imagine with me. The lower rod can go up below the upper rod. We could make a Y, okay, to cradle the upper rod and then pin through that Y. So that was the idea that I actually had in my head, even though I kept on talking about this other idea where you just come up alongside it and pin across. Again, technically still works, but not as ideal because now we're shearing against the bolt. Technically you're shearing against the bolt in a way, but it's divided across two different sides of the bolt. Now we're shearing only in one position on the bolt, that is pinning the two rods together. So, there's that. Okay. Now that I've got that out of my system. Alright. Ugh. On the bright side, I don't have to print extra plastic, I guess. I guess that's on the bright side. So, let's get these rods in here. Up here, hit the extrude button. I should just use the sketch and then offset it. The alternative is because we have this face right here, we could use the face instead, but that does not make as much sense. And distance to object, I will use this sketch point right here and make a new component. And this is the top handle rod. And we can go ahead and do the same thing on the bottom. Or Control Z. Rename this top handle rod. And I hit escape instead of enter because I'm a doofus. Alright, there we go. And get our sketch again. Turn that off. Turn this one on. This one. And the sketch is right there. So we technically could do it from here. And I think I will. So distance to object. That point. New component. Key. Turn that off. Rename this. Bottom handle rod. Enter. Rename, please. I wish double clicking or like slow double clicking brought up the rename. Unfortunately, it does not. So we will now take a look at this from the handle perspective. So as you can see, these are not overlapping, and it does not look like we actually dodged that. So again, I was thinking that we would dodge this right here. The way we can fix this is right now we're going direction on this guy at the bottom. If we change this to connected, and actually I guess change this to connected, okay, changing that also to connected does that. So let's see how skinnier we get. We did not get much skinnier, so I will just put it back. And it is one of those things at this point that just means that this angle is going to be slightly lower in real life. Now, at this point, let's see. I guess I will model in the connection pin. There's a couple ways to do this, right? I could print a cap, but I do not see the purpose. So we could print a cap with a hole in it, and then just drill a hole in this one. But if I'm drilling a hole in this rod right here to connect it to, I may as well also drill a hole in this rod, right? Makes sense? So I do not see the point in creating a plastic cap. Point being. So let us turn that sketch off. Grab ourselves a tangent plane. There. Actually, do I want to make the? Yeah, I will go ahead and make this in the bottom handle. Tangent plane. Our reference plane is the origin. Originio. There we go. And we are on the outside like I wanted. That's good. So we don't need to change the angle. And this is... I am in bottom, right? Yes. Rename. Oh, we can rename here. Why couldn't I rename before? This is outside tangent plane. Outside bottom rod tangent plane. And now we can go ahead and come back up the handle. And it is one of those things, at this point, it has occurred to me that I have goofed up a little bit on the organization here. So we are going to slap a band-aid on this, and hopefully the band-aid sticks. So this is right side handle. There we go. And then we can move these in here. There we go. So, yeah. Whoopsies. We're going to create a new component. Handle at handle joint pin. Okay, there we go. Go on that guy. Project out both of these guys. Toss my line in here. So in theory, I shouldn't have to do this, because in theory, the center point of this rod is exactly on the center point of the other rod. So I really only need the center point here. But just for reference, to make sure everything looks correctly, if I come back here and look at this sketch, I'm going to do it this way. And this is going to be an M... Well, what can I get away with? Let's think about this. An M4... I guess let's see how it looks, because I would like to go with as big of a bolt, so for example an M6, as I can. Let's see how that looks. And I want this on that center line. And actually I take that back, hit Control Z, delete that, and you need to be, let's see, let's give ourselves... Oh, okay. This is the pivot point right here, right? So our bottom rod actually needs to go past this pivot point. I could either compensate now or compensate later. I will opt to compensate later. So this actually will be on this line. I didn't want it to be on this line, but because we did not compensate to begin with, that is what we're going to do. And then we'll extend this rod out to compensate. And let's go ahead and leave ourselves a 1/4 inch of meat. Again, about 6 millimeters. I guess that's where we are at this point. And there is that. And we can go ahead and go distance to object. Let's see how this works. I can go through body, right? Yes, I can. And I can go... shouldn't it... What if I do this? No? Okay. Let's see. Because I want the end to be... Oh, that's what I can do. I can offset. Let's just call it... I don't know how thick the nut is on the other side, and it's going to have to be a lock nut. So that is going to be thicker. So I'm going to call this 8 millimeters and be happy with it. And is that face weird? Is that not flat? It doesn't look flat. Alright, there's different ways we can fix this. We can, instead of going to this body, we can set up a tangent plane on the inside here, and then go to the tangent plane. I'm going to see how this ends up looking, and go from there. Yeah, that is going to be my solution. I mean, it does look really kind of stupid. So, let us back up. Oops, no. Back up. There we go. back up here, go to top, construct tangent, there, find our origin right there, and 180 it because we want to be on the inside. And now, come back to handle joint pin, come back to that extrusion, change that to that, and now we should be flat. If we're not flat, something is seriously wrong. It looks like we're flat. So, come back here, let's rename that really quick. Inside tangent of handle rod, turn you off, and hopefully that just saved my name and doesn't magically disappear on me in a second like the other one did earlier. Alright, now, we need a top of this guy. Tangent, relative to this face, actually. No, not relative to that face. I take it back, I lied. I apologize. Relative to that face. There we go. Alright. So this is handle joint tangent to bottom rod, I guess is how I'm going to call it. And we need that so that we can come back to the bottom handle and extrude this up. Distance to object. That, again, if we did the other, you should be joining right now, so we need to come down in here. There we go. Distance to object. There we go. And offset, again, I was thinking, I think a 1/4 inch, about 6 millimeters is fine. So, now, how does this look? I guess, actually, what I should do is, instead of saying, how does this look, I should, let's see, turn this construction plane off, come back to handle, right side handle actually is fine, come to inspect, section analysis, we will grab one of our tangent planes. It doesn't necessarily matter which one we grab because they're going to look the same. So where's my bottom handle? Nope, no. Where is my outside? Oh, there it is. Outside bottom handle. And then we go in -4. There we go, because it's 8 millimeters. And I'm curious about that to that. What's my minimum distance here? Can I get a minimum distance? It doesn't look like I can. Oh, I know why. We could do this instead. Don't necessarily need the section analysis. What we can do instead is something we're going to end up doing anyway, which at this point we need to hit the combine button and combine that guy with that guy. Actually, let's do this inside of the bottom handle rod to keep things organized. Combine that guy, cut, keep tools, okay, and combine, or not combine yet, let's come up here. There we go. Getting the hang of this, right? Boink, boink. Combine, keep tools, good gravy. Alright, now. This is what I was curious about. We'll turn the handle joint pin off, and I should be able to, I think, get a measurement here. I cannot get a measurement here. So, what I will do is temporarily offset that guy, or actually come down here. There we go. Temporary offset. We're going to delete this in just a second, but take this in here, create this sketch, create this intersect, and then create a tangent circle here and get the radius. Okay, so we only have 1 millimeter of radius here, 1 millimeter of meat on a 6-inch pin, which makes sense because it's an 8 millimeter derp. It's an 8 millimeter rod. We're using an M6 right now, so 8 minus 6 is 2 divided by 2 sides is going to be 1. Yes, that is how math works. So the point being is 1 millimeter is not very much meat for this pin, to go around this pin. So this pin is now going to be smaller. Let me hit Control Z a bunch to get rid of that extra stuff we don't need. And let's see. Yeah, that's fine here. So we're good. Okay. So I will turn off this section analysis. And I didn't want to collapse everything. I was just trying to collapse some stuff. Thank you. Okie dokies. There's that. Alright, now we need to come down to the sketch. Hop in here, grab the sketch. Oh, we did not name that sketch. So we actually haven't named a few things, have we? Handle, joint, pin, size. Okie dokies. So we will change this to, let's see. If this is 4, that is 4 minus 8, that's 2 on each side. If this is 3, that's 2.5 on each side, right? 8 minus, that's 3 is 5, 5 is 2.5. I guess I'm comfortable with 2.5, I guess. So we'll call this a 3mm. I kind of wish it was bigger, but we don't really have many options. So this is now a M3. M3s are not nearly as big, the lock nuts I should say, for M3s are not nearly as big as M6s. There's a rather considerable difference. So the lock nut will not be sticking out as far on this side, but that doesn't really matter for the sake of this design. Let me hop up here and start naming some stuff really quick. We name this as handle joint pin. Let's see, we got that one, Handle joint pin size. This is, rename, a bottom rod compensation for handle joint pin. I'm getting rather verbose here. No, stop. Rename, clearance for handle joint pin. Rename, top rod clearance for handle joint pin. Okay. Rename, bottom rod. Okay. Turn you back on. Minimize that sketch. Where is my extrude here? We are going to change this to 5mm. Okay. Let us get some colors in here. Plastico. You can be beige, you can be brown. Cool. And then we need some steel. I hit enter. Steel. These will not be stainless steel. These will be regular steel. Rods are definitely not galvanized. I'll call them satin. That's fine. And then some chrome zinc. There is no zinc. I'll just call it chrome. It's not actually chrome, but I want to differentiate that this is a bolt and not a piece of steel. I mean, it is a piece of steel, but just wanted to look different, okay? And now, let's go ahead and toss this joint in here. Actually, we're going to join everything. We are going to join everything. We are not going to join everything. We actually still need the rods. Let's see. The rods coming out here. We also need the covers for them to attach to, but we don't need that immediately. We can put the joint in first and then add that in. So, we are not going to do that just yet. We will do that eventually. I'm just really quick eyeing it up. Again, aside from this guy right here, that's the only real issue. So, and again, all that means is just that this will be lowered down, is all that means. Yeah, that's where we're at. There's an argument that if I just extruded... See, I can't really extrude... You see how this bulges out to compensate? So that's why I can't really extrude it straight up. I maybe could extrude it up a little bit and then start the wall. That's definitely something that maybe I could do in order to not have as much of a belly here for this rod to run into. The other option is, let's take a quick look at this frame. Yeah, we don't have that much space. Let's check really quick. Let us check. So that is 6 millimeters. So I could move it out another millimeter or two. It will be very tight, but we technically do have the space. So I could come back to here, bottom handle, hit this guy, and add that to -2, or even -1. Hit there, and now we're not hitting. You see how we're not hitting anymore? So, there we go, there we go. We do have a further joint in here. This is not as tight as it was before, but that's not that big of a deal. So, anyway, let's hop back up to the top handle and extrude and go to the handle sketch and grab that. And let me turn these guys off actually really quick. Those guys off. And I want to make sure I'm going from the wall here. Object. Turn the sketch off really quick. And make sure I'm clicking a face here. Okay, I am clicking a face. And. Turn these guys back on. Go to the outside of the bottom one. Or actually, +4, yeah. Outside of this one, +4. And as you can see, that gets us mighty close. Actually, +4 may be a mistake, because we should have a little bit of backing for it to not slide out. So we might want to go +3. So this is not going to be... On this side, this collar is 4. The collar on this side might only be 3. And the outside wall may only be 1 millimeter right here. Which isn't great, but we really don't want to be rubbing up against the frame here. Now, that being said, I could make the frame a little bit wider. I've been constraining myself on space here, and it may just be me being stupid. I could probably compensate with the frame to give ourselves more room, and therefore this whole entire bulging thing right here would be completely unnecessary. The one counter argument I will make is that okay, so it's hard to make the argument. Basically, what I was going to say is that I'm using less plastic this way. If I took this out, this is 12, right? And it's supposed to be 16. If I took this out to the 16 so that everything is flat, then I'd be using more plastic. The question is... Alright, there's actually no. I was going to say, would it be easier to print this laying down in that case is what I was thinking about. But it's actually not easier to print it laying down. Even if I square this side off, even this side, if this side is just a square, and it could print on its side, this hole in the middle then would still need to be reamed out to accept the rod to begin with. So for that reason, it actually doesn't matter. We can print this instead upside down. So imagine this loft on the floor. So this is on the build plate right now. All right, here we go. Print it like this. So we could print it like this, and it's basically the same thing. And this through hole is a lot easier to ream out than this blind hole right here. Is the thought process, is the reasoning. So it actually doesn't change any difference, and we can keep the frame smaller by a few millimeters on each side, like this. So yeah, that is where we're at. There's that. This is the top handle pivot shaft is what I will call it. We will go ahead and rename that as well. Pivot shaft. Come down here, do the same thing. And as always with this one, do not click that base, click the sketch profile, por favor. We can just go ahead and mimic the top one. There we go. New component. Okay. Open this up. Rename the bottom and rename. There we go. There we go. Now we can put in joints. Right side handle as assembled joints. Actually, let's start with rigid groups really quick. And let me turn this handle joint pin back on. And we can turn that sketch off because we are done with it, hopefully for forever. So. Let us see. Yeah, I will go ahead and do the rigid group. No, I will. See, it's not really a rigid group because it's only two things. It's just this and that. I mean, I'll do rigid group anyway, just in case. Oh yeah, it's gonna end up being a rigid group because I need to add something to the top of this one. The bottom one, not so much. The bottom one should always only be two pieces, but again, we will just go ahead and use rigid group anyway. There's that. All right, now as built joint. That guy, and revolve around the inside here. Let's see if we can get the inside here. I'll turn that off really quick to get the inside. There we go. All right, so that is now revolving there. Come up to the top. As built joint. That guy. Turn that guy off so we can get the inside. There we go. And I might have done that backwards. That guy. That may not have been correct. That guy. Oh, I see what's going on here. I see what's going on here. Stupid. Okay. We're going to hit Control Z a few times. Control Z, and I think that's all I got to do for Control Z. Again, organization is important, so before we do any of this body I just left in here, this needs to be its own component. Pivot attachment, top handle pivot. Alright, this one needs to be its own component. Create component from bodies. Bottom key. Alright. Now we need to throw the rigid groups back in. There we go, new children. And down here, rigid groups, there we go, new children. And now we go back to revolve. As built joint, that guy, and that guy. And there we go. And hit OK. And come back up to the top. We'll get there eventually. We always get there eventually. Kind of. Sort of. I wish we always got there eventually. Sometimes we don't, actually. Which I am not very happy about, but that's life. Alright, that's rolling. That's revolving. Modify. As built joint. Revolve that guy and that guy. And I guess revolve around that. And then, oh, I was on top of handle when I did that. So let's Control Z really quick. And we can go ahead, however, and do as built joint that and that with a revolve on that. Bottom handle. Now these joints that I'm making, show up in the top level anyway because it's between two components of at the same level, not nested, not children of each other. So it doesn't actually matter where I put this, it will end up in the correct place in terms of organization. So. That is my joints. Let's see. I guess I will make this rigid, and in that case we gotta come up here, modify rigid group, do not include children, this guy, that guy, okay, and then rigid group, turn that guy back on, that guy, no children, okay. And I think at that point, I think we are kosher at that point. So, if we revolve this, okay, we still need that one. Okay, that's cool, that's fine. We come up to carriage, and again, this would automatically sort itself out correctly, but you know, that is just regular joint. Let me really quick. How do I hide this? I want to pin this guy, pin the tool, and then unpin that guy. There we go. Now I have the as-built joint always on there. Alright, changes that should have happened forever ago and have not. So, I believe, let me check this really quick. Yeah, I believe all that is rigid joints already. So I should be able to, how do I define this? Let's turn that off really quick, and let's define this guy to this rail. Which one's this rail? That one. There we go. And this is going to be a slider. And we can go ahead and just grab the middle point there. And because that's rigid, that should now work. So let's turn everything on and pray that this works correctly. So when we pivot the top handle, that did not work correctly. All right. Control Z. Where is this guy right here? Control Z. Let's slide you. Yeah, okay. So this guy is not actually connected to the main body, it looks like. Let's see, rigid group. That guy. Yeah, that guy I wanted. Can I edit you, please? Edit rigid group? Thank you. Oh, okay, that is that. Oh, so my joints, where are my rigid groups that are keeping all this together? Rigid group, edit, wait, no, cancel, don't break anything. Where is the rigid group holding the, that's the frame, that is that. So where is my rigid group that holds, wait, slider? Oh, that slider. Okay. So this slider does that. Okay. I see you. Let us see. I do not see the other, yeah. So I do not see the other one sliding out. Let's see. So where did I put that joint that's holding this stuff together? Oh, right down here. Edit rigid group. No, that's this one with this rod. That's the one I just made. Huh. I am lost. Hello, lost. Joints. Rigid group. Edit. There we go. That's the one. Okay. let me do this really quick. Okay, those are still connected. Good. Let me bottom carriage, lower carriage, whatever we call that. I have top and lower. Somebody hit me. I am clearly not functioning correctly. So, actually, really quick. What rigid group are you in? Because obviously you're connected. Oh, you're not connected. Huh? Okay. Rigid group. That. Don't include children. Both of these bearings in that. Okay. Okay. Actually, let's go all the way up for the full effect. Did we finally do it? When we move the top handle, it does. I think I saw something go weird there, but it does. Yeah, why is that frame moving? Let's try that again. See if it happens again. Huh. Why does the frame go up? More importantly, why does that frame not go? Why does the frame hop up when I first start dragging it, but doesn't hop back down when I change direction? That actually doesn't make any sense. Huh. But anyway, here's our handle. Or at least the right-hand side. So that's how that would work. We lock this in place and then do that. And I'm going to go ahead and hop in here. Let's see here. Into handle. Into right side. And put a connector piece on the top here. Again, different ways to connect this. I think going across the top makes the most sense. Like above the rod. So, one of those things. Allow me to demonstrate. Come in the top handle. Actually. Go tangent. Hit that. Find our origin, because I already turned the origin off a few minutes ago. Find the origin plane. There it is. Attempt to click the origin plane. Please let me click the origin plane. Huh. 0. Click. Why can I not tangent to... Huh. 90. Alright, well, that's where we're at right now, I guess. Okay. Yeah. Actually. How do I want to design this? I just realized I may not want to design it that way. I actually may want to design it this way. We are still in top, right? Constructions. I do not have top of handle, right? Correct. I should know this because we just did this session. So minus, let's say, I want to go. All right, it's going to be 8. It's going to be 8 plus just 4. I guess 8 plus 4. No, 8 plus 8. 8 plus 8 is 16. Yeah. 16. Okay. Alright, so I'll do it this way. Let us project out this rod and then turn everything else off so it's not in our way. Off. Minimize. V. Find the rest of the stuff. V. Alright, cool. So there's a rod. Here it, well, no, see, that's the problem. Not there. Actually, you know what? I can do round. It's not unreasonable to do round. just for the looks of it, right? Yeah. Yeah. So this is going to be 8 millimeters. This is going to be here. That should not be there, though. This was going to be here. That Stop it. Stop clicking the things I don't want you to do. All right. Go vertical. Quinkydink that guy. You go tangent here. And you are actually a whatchamacallit. And you are not a whatchamacallit, a construction line. And we need 4 millimeter wall here. 4 millimeter wall here. 4 millimeter wall here. I'm doing these separately even though they're the same number for reasons. And that is also construction line. And now we can square this up to make it look nice and pretty. Did I double line there? Okay, I did not double line there. Amazing. I have gotten through, knock on wood, but it appears that we are going to get through a whole session without Fusion hitting me with the magical Fusion double line. So let us do this. How is this printing? There is no good way for this to print. So I guess it doesn't matter. Yeah, I guess it doesn't matter. Okay. So we are going to go, what was it? 8 and 8 is 16? 16 millimeters? Actually, I don't even need 16 millimeters. I can go to object. Turn the rod back on. There's the rod. And we can go to object there. And this is a new component. There's that. I am hesitating here because we actually probably, I made this pretty like this with the round top, but I probably should square this side off anyway. So this is going to be tangent. That is going to be tangent. And then we will adjust this selection here to that. Okay. There we go. This is the handle crossbar holder. Copy, rename, paste, key, hop in here, grab this outside of handle crossbar holder, rename, grab, project that guy, toss an 8mm circle in here, go here. Actually, this can just go here. That's all we need it to go. Change some of this to construction lines. Change that back to not a construction line. Make that tangent. Tangent there. And centered. There's center. There's that. And right angle. And there we go. Extrude that out. Distance all. Flipperooski. Make sure we are not cutting anything we don't want to cut. Make it a plastic. Haven't used brick red yet. And there we go. So, come up here, come to handle. Turn some more stuff back on. And create mirror right side. Oh, actually. Top handle attachment. What do you hold? Yes, you are exactly the one I want. Come down here, please. Thank you. Edit. Include that guy. Okay. Alright. Now we create mirror right side component. There we go. Right side. Across our origin, which I guess is that one. I don't know which origin this is. I guess I'm about to find out. That's the carriage origin. I am going to attempt to not grab the carriage origin. Alright, that's our original origin. That's good. And okay, now that is going to break all my hinges, so we will have to realign those, but in the meantime, we are in handle. We will create a new component, and this is the crossbar, and we can go ahead and extrude from that sketch. That is not the sketch I was looking for. Obviously, I clicked the wrong thing. Where is... There's that, and there is that. There we go. Distance to object. That guy. New body. Okay. Rename. Handle crossbar. Okay. And now. No. This is the... Actually. Where's my rename? Handle crossbar holder. Crossbar hole. I guess that's where we're at right now. Okay. There is that. It's one of these things. I am not going to bore you with throwing all those hinges, those joints, back into here for the left-hand side on stream, because that is just tedious work at this point. Although I will really quick change that. I just realized to left side. I'll leave the mirror in there just for reference. And we will hop up here, and I believe I also need to name that mirror. Alright, I need to rename more than that. Rename, this is... There's that. Left side creation. Left side handle creation. And this is renamed to crossbar. Oh, we already have that. Cool. Groovy. Alright. There we go. There we go. So, that, with the exception of the base, is everything. Now, as I stated, the base could actually be a number of things. We could even design the base on the fly. This is the only part of it that actually matters. So we are effectively done. I'm going to call this done because putting a base on this doesn't necessarily matter. So the only things that I would have left to do, and actually we can do those really quick right now anyway. So I am going to extrude that. Let's see. Here's my mirror for that, right? Yes. Do I have... It does not appear that I have the screw. Yeah, it does not appear that I have the screw hole just yet when I do this mirror. Yeah, when I do that mirror. That mirror, that, then that. Okay. So I will do... Let's come here. No, not rename. I'm trying to roll. There we go. And let's find that sketch really quick, which should just be right here. Grab that. Distance, all symmetric. Cut. And include. So we got the rails, holders. And it doesn't say frame, but it should also be cutting the frame. I don't see frame here. Oh, top bar and bottom bar. Those are the frames. Okay. Okay. Oh, I haven't named any of my bodies. Alright, organization is bad. Forget organization. There we go. This has holes in it. Everything has holes in it. There are holes in everything. In case I'm not being redundant enough. Let me hop back up here. Go to the end. Alright. Turn this sketch off. Find a browser. Goodbye. Turn that off. That's just that origin. We can turn these off. I'm hitting V, but it's not actually going away, which is annoying. I could have swore that you could turn them off like this. Show hide. Yeah, see V. There we go. Oh, I have to click off first. Derp. So this is the only joint I need right here. That guy. Find the browser. Handle. There we go. These are, this is the one joint I need on this whole entire thing. Try that again. There we go. So, once I get, only thing I gotta do off stream is A, name all these bodies, which, whoops, forgot to do that. B, add the joints into this left-hand side, which again is just tedious work. And C / number 3. Actually, I'm just realizing, you see how this actually goes outside of my extrusion? I did not realize that, so I am going, okay, we actually, that is good to know in the future. The last thing I need to do is just design a base, and again, that can be done, honestly, outside of the design. It can look however I want. I obviously will model it up, because, again, if you listen to my talk this afternoon, I did a chatting just catch up because I was off from streaming last week. If you listen to that talk, you'll know that I want to actually put a milling table more or less on the bottom here. Again, it is frankly, it is effectively no different than any other CNC 2-axis table when you get right down to it. I may do it with linear rails instead of the V-rollers, but regardless, that is where we're at right now. I want to do that for fun, more or less, because it is going to very quickly become obsolete, frankly. Basically, when I'm hand routing these PCBs, it'd be nice to be able to put the PCB instead on this thing and more precisely route it with the PCB than by hand. But as previously stated, again, especially if you listen to the talk, I will be getting a desktop CNC machine in sometime this year. It is currently, let's say, back ordered. Again, by all means, feel free to watch the video earlier if you want to know what exactly I'm talking about. And I'm only saying that because obviously I want view time. Obviously that's the only reason I'm saying it and being cagey about this. I'm greedy like that. So at that point, once I get the desktop CNC, bollocks, I just realized we didn't do the covers on these guys. Dang it, I'm looking at the time here. I'm like, 2 hours. We're going to be done under 2 hours. We still need the covers on these guys. Alright, so here's the deal. The covers actually could pose a little bit of a problem, potentially, because I need to work around these guys, because I need to work around these pivots, and it needs to be strong enough to support this rod right here. That is my biggest issue right now. That is why I kind of want to do it on stream. At the same time, it has been 2 hours, and I was hoping not to spend 2 hours on this, which is why I was getting ready to wrap up. So, let's see. Solutions. Solution number 1. I take these rods, and I super glue / epoxy them into the plastic. These are very short rods. Again, these 8mm rods, technically they're 5/16 for me. But I get them out of the trash at work. That's how I get mine. So epoxying them into this thing is no big deal for me because I can just throw the whole entire thing out. Effectively speaking, I can break it out and then throw out that rod and not worry about reusing it. At that point, we do not need support on the other side, ideally, hopefully. Let's see. The support for this one right here, let's just talk about it. I mean, that is upsetting. That is upsetting. We'll roll back here before I mirror the other side across. Yeah. So the support for this one, because we have the wing right here, actually can look like this. So let us go ahead and find the outside of the top carriage. I'm pretty sure I have the, yep, we do have a plane there. So we can grab this, project out that, let me turn this thing off so I'm not actually staring at it. There we go. And actually turn the handle back on really quick so I can grab this. Okay. So this one is actually quite easy, I think. Alright, easy is a relative term. It is relatively easy because what we can do is let us turn the bodies off and turn the handle back off and the frame and the rails. We can do this. We can grab that and go like this. And there we go. That's hilarious. Okay. So having to stop and not actually finish the stream caused me to get the mystical fusion double line that I knocked on wood saying we would not get this stream. That is pure comic gold. That is beautiful. So this is going to be extruded. Did I select everything I need to? I think I did. Okay. From object, let us turn some stuff back on. Where is my handle? There it is. That is not my handle. I can't see my handle. That's why my handle is not here. So from there, and let's see. We do have the outside of that we're working with, so we could actually use the outside tangent there. So let's go ahead and grab that since we have it. Left side, right side. Left side, right side. Oh, this is... Wait. Huh? Left side handle. There is no left side handle. Oh, did I not move? Oh, I did not move far enough back. Okay, well, whoops. It does not actually matter. It does not actually matter that I didn't move that far back. It's just one of those things. I'm just going to make things a little bit more interesting. Where's my outside of... oh, bottom handle. That's why I can't find it. Bottom handle. Alright. We're almost done. We're almost done. I'm just trying to find that in the viewer. There we go. I just want to make sure I selected the correct thing. And the funny thing is that it... There we go. That is what I wanted. Alright, so distance to objects. That guy. So this one again is easy. This one's easy because we can just come off the back wing. And this is... Yo, Ben and Gail, thanks for showing up, guys. Stream is going very well. Thanks for asking. Did we have D&D today? My phone has been on silent. Oh, okay. So... Huh. Whoopsies. I was not looking at Discord all day because I've streamed, 4 times today. So, and evidently I didn't look at Discord yesterday either. My bad. Yeah, I should have been done about 5 minutes ago, more than 5 minutes ago. Not that that would have helped anything. Anyway. So the top one was easy. The bottom one, bottom handle, is a little bit more difficult because obviously we're right up against this thing. And we have this little, that bulging actually should, yeah, we got that bulge right there to work around, but that should be above this circle right here. And we do not have the back wings. So this may be a good excuse to put the back wings in, is what it's probably a good excuse for, to simplify the design. So I think I will do that really quick. Lower carriage will come in and put the wings back in, not put the wings back in, but put the wings in to begin with. I guess I want to come up here to the carriage body. It should hopefully be less than that. I just got to find where these wings are at. Okay, there are the wings, so I just got to hop over here. Let's see. I can use the back of top carriage. Let's see if the lower carriage has its own back of lower carriage. It does not, so I'll just use the back of top carriage. Control Z. Let me make sure I'm facing the correct direction here. There we go. Project that out. Project that out. I'll just project the upper wings because all we're going to do is match the upper wings. There's that. There's that. Or actually, before I do that, let me construction line everything. Alright, cool. That did not actually catch. There, 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 and there. And then we just drag this circle straight down here. And we can put it centered on here. There we go. Toss the circle in. X, X. And this is going to be equal to that guy. Alright, extrude that out. Where's my sketch at? There it is. Distance to object. Again, for the bottom one, we always just mirror the top one. It just makes our life easier. And what do we call this sketch up top? Let's rename that to top carriage. There we go. Again, just copy paste to make our life easier. Paste. Who's DMing today, by the way? That, everybody, is what we call a joke. I'm DMing. Whoops. The DM's late. DM's horrible. Alright, let's find where we were at with... oh, that's right, I gotta mirror this first. Create, mirror, feature, that guy, origin, there we go. Alright, and now we just need those supports. So now I just gotta track down these supports in the timeline to get back to where we were at. Should actually be right about here. Evidently not right about there. There? Alright, there it is. So again, we can... What plane was I on for this guy? Okay, I was just using the outside right-hand side plane. And this is the top carriage handle support. Copy, paste. Rename. Okay. And again, grab the correct component first. There's the component. There is, oh, we don't have an outside right. So, again, being lazy, we're using other planes. Project out that stuff. And the handle rod, make sure we got that. And we will do the same thing as we did before now that we have the back wall. So, body off, these guys off, just so I can see what I'm working at. Tossing these lines. Tangent and tangent. And that may Yeah, that actually may not work. We'll see what happens. We'll take a quick look at it before we hop off. There's my extrude. We're going to go from the handle this time. From object, handle, and to object, that guy. Turn the body on, hit the join button. This is not as thick, as you can see, as the top one, which is a little concerning because this is actually the one that receives more weight. There's one thing we can do. Yeah, so back to this is what I was talking about. The circle again is probably fine, but I probably can't go tangent like that. I probably gotta go tangent straight back. So we'll correct that really quick. Let's see, that line right there. Yeah, that quinkydink right there. And we'll make this a right angle. Finish. Okie dokies. And that does look like it's clearing it. Again, we have a little bit of space between that and the frame, so hopefully we'll be alright there. Turn the origin off really quick. Turn the origin off really quick. And let's see. The last thing I was thinking about was just throwing a strut along the bottom here, but that's probably one of those things that I'll find out later. Again, we got about a millimeter or two between here and here that we could fatten this up, but we'll do that if it breaks. We'll go ahead and let it break first and then improve if necessary. If it doesn't need it, it doesn't need it. So turn that stuff back on. Turn that stuff back on. Handle it back on. And come all the way back up top. Hit the end button. And there we go. Alright, now we should be done. And now we can lock both of them in place for extra rigidity. Again, that's the pressed piece right there. So we are groovy. And again, as I said, since I got to redo the outro now, I will link up the other side, the joints on the other side off stream, and I will design a base for it. Again, the base is non-consequential. It doesn't actually do much. So that is everything. I'm going to call this done, and you will get a project update eventually when it's actually built. So if you have been watching, thank you. And as always, I hope you have a great and wonderful day, afternoon, or evening, wherever you are in the world. And I'm going to go play D&D.